In this video, we are going to start building our perennial stream network by populating the StreamType field of a flow network. Alright, so we have the hydroconditioned DM and associated derivatives. We've completed the first step of the three-step process by delineating a flow network using one of the two methods. And now we're moving on to the second step, where we get to manually identify which segments are perennial. This is an important step, as whatever we define to be our perennial network will become our stream reach, which we use in later tools such as the runoff risk or the riparian assessment suite or the nutrient removal wetland tool. So let's get started. It's important to take your time in this next step in populating the StreamType field. What you do here will determine your stream network used in all the other ACPF tools. So our goal is to properly identify perennial stream networks. And perennial streams mean streams that have continuous flow all year round. It's important to do this because management for perennial streams compared to ephemeral or intermittent streams or ditches is a different process. So what we'll be doing in this step is going to the StreamType field of either flow network we choose, either area threshold or Puke or Douglas, and then assigning a value. For example, you could use 1 to indicate perennial streams and then keep the zeros to indicate your ephemeral or intermittent streams. It's important to note that the classification value must be an integer. We can use some of the information that we already have, like that Strahler stream order, to speed up the process in classifying some of our perennial streams. However, you still need to go in and do some manual inspection and then editing to make sure everything is accurately coded. If you're still not sure how to apply this concept to map the extent of perennial streams in your watershed, try thinking of this task from an ecological rather than hydrological perspective. One of the key reasons to install riparian buffers in a watershed is to protect the aquatic habitat that is part of the stream system. A good way to think of this is as an exercise to define or predict where aquatic plants and animals can be found in the watershed. Ephemeral and intermittent streams may have filter strips installed alongside them, but these are not exactly riparian buffers, which play a role in protecting or sheltering the aquatic component of the watershed ecosystem. Basically, you are trying to define where riparian buffers can fill this specific role. Alright, so we're back in our map document. I have my pour point, my Puker-Douglas flow network, and the area flow network. So we're going to begin populating our stream network. And first off, we need to choose which one we're going to be editing. My area flow network, shown here in green, extends further up than my Puker-Douglas flow network. So I'm going to choose this one to ensure that any channel that I believe to be perennial or one that I am interested in, maybe for later tools to be ran with, like the riparian assessment suite, will be included in my perennial network. If you would prefer to use your Puker-Douglas flow network, that's perfectly fine. And if it turns out, if you are using it, that it does not extend up far enough, don't worry, we can append a section of stream from the area flow to the Puker-Douglas later on, and I will show you how to do that later. So I'm just going to turn off my Puker-Douglas since I'm not using it, and we can begin editing our area flow network. So to begin, we'll start an editing session. So I right click, go to Edit Features, and start editing my area flow network. The first thing I want to do is clean this up a little bit. I have all these flow paths outside of the watershed boundary that I'd like to get rid of. So I'll go to Selection, Select by Location. I'm going to select features from the target layer, which is the area flow network. My source layer is going to be my watershed boundary, and I'm going to choose the spatial selection method of intersect the source layer feature, meaning any flow network piece that is intercepted by the watershed boundary. I hit Apply. We see that everything inside the watershed boundary has been selected, so I hit OK. And since my intention is to get rid of things on the outside, I'm going to switch this selection. And then I will simply hit this X to say delete those selected things. And now you can see everything is a lot cleaner. All right, the next quick jumpstart move I'm going to do is select stream segments that have a trailer stream order of at least 4 or greater. So what I'll do is hit select by attribute, go down to this trailer stream order, greater than or equal to 4. I hit apply, and I take a quick look at all of this and see that the main channel has been selected and some of these larger branches. So things look good to me. So now in the StreamType field, I'm going to right click, go to my field calculator. I'm going to assign these a StreamType of 1. And I hit OK. And now I can see that these do in fact have a different StreamType value. So something that I find helpful to do once I begin defining my perennial network is to go into the properties and symbology and to start symbolizing it by that StreamType value. So we'll go to StreamType, add all values, and we see we have that 0 and then a 1. So I'm going to give my value of 1 a thick blue, and then my value of 0, I'll just make a light green color. We hit apply, OK. And now for me, it's very clear where my stream is. It's that thick blue, and the things that I have not assessed yet, or at least changed, are in this thinner line. And this just helps me keep track of what I've done. Another good thing to do is to right click, go to selection, and make this the only selectable layer. While you're in an editing session, it's easy to grab things and make some errors. So this is just a good practice to do whenever you're in an editing session. So now it's time to go segment by segment, deciding where your perennial network is or where the channels of interest are. I recommend going segment by segment, working from furthest downstream, going upstream. I feel like this will help you prevent missing segments along your way. And it's also helpful to use things such as your hillshade, where you can see the channel in size. You can see smaller channels as well within the hillshade. But on top of that, definitely using some imagery as well. I have some imagery sitting on a server I'm connected to, which I find to be very helpful. So if we look without it, say in this section, with just a hillshade, I may wonder if this is an actual channel or a gully, or maybe even a ditch. And when I turn on my imagery, I can see that it looks like it is a channel further down here, and that it could definitely benefit from some riparian practices since it's in the midst of all this agriculture. But it can be very handy for making these distinctions. An add-in that I'm a fan of, and it's called this SIG GIS Aerial Street Viewer add-in. So I can go ahead and say add this in. All right. Boom. And then close. And we can see there it is. So I'll just throw it up to my toolbar here, bird's eye, and then no matter where I click, imagery pops up. So I have an idea of what my stream is actually looking like. And there's a year supplied on here, so you can see this is from 2010. And this is just very helpful. It kind of gives you that oblique view, so we can see the road crossing there. That's that stream segment. And this will be very helpful for identifying your perennial network. You'll notice that sometimes you can also rotate so get a different look at it, which can be very helpful in times when you have vegetation blocking your view, or maybe a shadow. You can just keep rotating until you get a good view of the stream system. So here's an example where, based on my hillshade, and then if I use this bird's eye viewer again, I can see that my channel does actually extend beyond here, although that classification by the Strahler stream order did not include this more upstream segment. So I'll use my select tool and start selecting these segments that I believe should be included. Remember that to select multiple segments, we'll hold down the shift key and just keep selecting. I can pan through this bird's eye view and just keep going. I can see it does continue. We actually have another fork here and it seems to continue both ways. So I'll just select these next few for an example and then go back into my attribute table. I see that I have these 6 segments selected. So I go to StreamType, right click, field calculator. I want to make these ones. So I hit OK, and now they're all ones. And we'll continue through this process until we feel satisfied. If you ever get lost using this bird's eye view, you can just click again, and it'll move you to where you, at least nearby where you were. And like I said, sometimes it can be kind of hard to tell even from imagery. I highly recommend adding aerial imagery to your map document and adjusting the transparency so you can see the hillshade underneath it a little bit. But just keep moving your way through the network and select new pieces to add to the network. So here's a segment that I would like to count as a value of 1. It's fairly incised. When I previously looked at some imagery, it does appear to have flow. So I would like this to be recoded. However, I only want this shorter segment, not this entire stream segment. So I'm going to need to conduct a split in order to just get the portion that I would like. So I already have that segment selected. And what I can do now is, using the editor, go to the split tool and choose to split it where I see appropriate. This is a road feature that it's crossing, and some of our later tools, especially within the riparian assessment suite, will not cite practices if they intersect a roadway. Because I know this, I'm going to choose to split this where it's downstream of this road, so there's a chance that practices could still be cited along this segment. So within my hillshade, I can see where the road is. It's right around here, and I'm going to choose to move a little bit downstream of that. I can see by this white line I'm within my field boundary now, and select. And now you can see that I have split this segment into 2, where here is the upstream portion and here's the downstream portion that I'm interested in. And with that selected, I can open up my attribute table, go to the StreamType, and give this a value of 1. And now when I deselect, we can see it's included. So as I mentioned earlier, I chose to use my area flow network because I saw that it extended past my Puker-Douglas network. But there's still a chance that there may be places in the watershed that even your area flow network just doesn't extend high enough up in the watershed. What do you do in this case? Well, you basically have 2 options. You can either start over and redelineate your flow network using a lower area threshold, but if you rerun that tool, that means that everything that you've originally changed to a 1 is going to go back to being a 0. So we don't really want to do that. Secondly, what you could do is create another area threshold network. Just name it something different, maybe area network 2 or area network rerun. And then you would just select the section that you want to add to your current flow network, and using the append tool, add it to your original area flow network. What you do not want to do ever is digitize what is missing. You do never ever want to manually go in and draw a line that you would add to your area flow network. it is not going to align to your LiDAR-derived flow direction, and therefore you will not be able to run future tools to get your stream reach. You may be saying, but what if I was editing my Puker-Douglas network and that doesn't extend far enough up? What do I do then? Have no fear. You can select your perennial stream using either the area threshold or the Puker-Douglas network, and if you run into this problem, you can then append a segment from the area threshold to the Puker-Douglas network. It's still going to match up to your flow direction roster, so everything will work out fine. And if you notice, the Puker-Douglas and area threshold networks have the same fields in their attribute table. So feel free to select a segment from either network and append it to then either network that you choose. This is a time-consuming process, but it's very important that you do take your time through this and make sure that you got every segment that you think could be a part of the perennial network. It may take a while to orient yourself in your watershed, especially using some of these add-ins to get an oblique view. But they're very valuable tools. See, in this instance, it's sort of hard to view from this side if that has water flowing in it or how incised it is. But then with a quick rotation and making sure that I'm still looking at the right segment, which I am, you can see that it is a fairly incised channel here, and it's not just a shadow. So I know that I do want to include that in my network. It'll take a while to get a feel for what you would like to classify as a perennial network, and it may vary based on what you're going to be doing. You just need to be able to make the decision beforehand and make sure that you keep track of your coding and editing process. I'd like to point out that in this example, we just simply were coding a perennial stream network using a value of 1. However, you can go into a lot more detail with this. You could say use a value of 1 to mean a well-developed channel, a value of 2 to indicate maybe a braided channel, value of 3 to designate ditches, maybe a value of 4 if you have a flow path that goes through a farm pond or maybe through a dammed reservoir. My point is, you can get very detailed with this process. Just make sure that you keep an equally detailed record of what your identification numbers mean, and make sure that you're always using integers as your identifier. I'd also like to point out that you should be very aware of landscape features and what you're coding. For example, just by looking at aerial imagery in a hillshade, sometimes a gully can appear as a well-developed channel when in fact that is a problem within the land that could be treated or mitigated with a conservation practice. So we would not want to code a gully as part of our perennial network because we do not want it to be excluded from future conservation practice sightings. So this is just basically a PSA. Be aware of your landscape features and also feel free to get detailed and creative with your coding of the stream reach. Here's a brief recap of everything we just did in the video. I would like to reiterate one last time that you should never, ever digitize your flow network. It will not match up to your flow direction roster, and therefore future tools will not run correctly. They will not run at all. If you need to extend your network further up, either rerun the area threshold, saving the output using a different name, and then append that value to your original area float network, or just rerun and restart the coding process, although that's probably not the method that you should choose. All right, now let's go and develop our stream reach and catchments.